The title of today's paper is Global Apparent Temperature Sensitivity of Terrestrial Carbon Turnover Modulated by Hydrometeorological Factors, published in the Nature Geoscience, in 2022. The ecosystem carbon turnover time, an emergent ecosystem property that partly determines the feedback between the terrestrial carbon cycle and climate, is strongly controlled by temperature. However, it remains uncertain to what extent hydrometeorological conditions may influence the apparent temperature sensitivity of tau, defined as the factor by which the carbon turnover time increases with a 10 degrees Celsius rise in temperature, Q10. Here, we investigate the responses of the ecosystem carbon turnover to temperature and hydrometeorological factors using an ensemble of observation-based global datasets and a global compilation of in situ measurements. We find that temperature and hydrometeorology are almost equally important in shaping the spatial pattern of ecosystem carbon turnover, explaining 60 and 40% of the global variability, respectively. Accounting for hydrometeorological effects puts a strong constraint on Q10 values with a substantial reduction in magnitude and uncertainties, leading Q10 to converge to 1.6 plus or minus 0.1 globally. These findings suggest that hydrometeorological conditions modulate the apparent temperature sensitivity of terrestrial carbon turnover times, confounding the role of temperature in quantifying the response of the carbon cycle to climate change.